welcome to today's class. Today we will be talking about the concept of squares of opposition. Now this is an important topic in philosophy. So basically, why we talk about this topic, let's first discuss that. In philosophy, we have a concept known as logic. And what does logic imply? Logic basically means trying to understand the relationship between things. Okay? So whenever we are talking about logic, in that logic, we study square of opposition. Now, in square of opposition, what we try to do is, we try to find out relationship between propositions. And we call these propositions as categorical propositions because we have some categories that we are defining for all the propositions. Okay. So, under this, what we basically do is, this concept or this diagram is what is known as a square of opposition. Okay. So we mention it by four terms, that is A, E, I and O. Okay. So what does these terms signify? Now A and E are terms that are universally applicable. Okay. So if I have this diagram, okay, what I can do is, I can say the top two terms are universal in nature and the bottom two terms are particular in nature. Okay. So I am saying the black outline signifies the universe. The universe is the set of complete objects. So I demonstrate it by means of blocks. Okay. So under all these four, I am trying to make statements, and what I do under square of opposition is, I'll find or I'll try to evaluate one proposition with respect to another, or I'll find the truth proposition of, for supposedly A, when I know the truth proposition of O. Okay, for example. So what I'm trying to do here is, the top two terms signify they are universal in nature. That means A shows all the blocks are red. Okay, so for A, my proposition is all blocks are red. Okay. For E, my proposition would be the reverse or the opposite of it, that is, all blocks are not red. That means, for example, I am taking the blocks as green. So I am saying all blocks are not red. That means that the blocks are green in color. Okay. So this is the universal propositions, the top two. Now move on to the bottom two. They are particular in nature, as I have mentioned the word some in both of these. So the first says, some blocks are red. That means, if I have two or three blocks, okay, at least one block should be red in color. Some blocks are red means you have at least one block, at least one that is red. Okay, and when I say some blocks are not red, that means I should have at least one block that is not red and that is green in color. Okay, so here at least one should not be red, here at least one should be red. So therefore, the lower two terms signify particular objects and the upper two terms signify universal or the universe. Now, this is something I have divided them horizontally or top down. Now if I divide them left right, I'll see both the objects towards the left are affirmative in nature because it says all blocks are red and it says some blocks are red. So both are positive in nature. So this side of the block is affirmative in nature. Okay, and this side of the block, okay, says no block is red and some blocks are not red. So there is no and no in both of these. So it's a kind of negation statement. Let me write it as neg. Now how do we remember that we are using the words A, E, I and O? The simplest way here is, within this, if I see A is here, okay, and if I see I is here. So I am picking word A and I from affirmative. So these two would be positive statements. And I am picking words E and O from negative or nego. So these two would be the negative statements. And since A is before I, A will be universal in nature, I would be particular in nature, E would be universal in nature, and O would be particular in nature. Okay. So this is how we understand why we are taking A, E, I and O. And what is the four terms that we are using here and the four statements. Now we will be understanding the concept of squares of opposition and all the four terms here just by means of these four statements to avoid any kind of confusion. Okay. So first we will start with, now before we start with this, let me first explain the relation between A and E is contrary, between I and O is subcontrary, between A and I and E and O is subaltern or subordination that we call, and the relation between AO and EI is what is known as contradictory. So we'll start with the easiest one, that is contradictory. Contradictory, as the name proposes, is contradictory to one another. That means it opposes one another. So if I am saying A is true, that means O must be false. Or if I am saying A is false, O must be true, and vice versa for if we start from O. Okay. So let me first start with A. Okay. If I am saying A is true, that means all blocks are red. If that statement is true, I cannot say some blocks are not red, because since all the blocks are red, there is no block left which is not red. So if this is true, if I am saying this is true, this automatically becomes false. T stands for true, F stands for false, and all the truth propositions, all the universal propositions here are truth, and all the T here are marked in black. Okay. So if I am saying all blocks are red, that means some blocks are not red is a false statement. On the other hand, if I make it false and if I say all blocks are not red, that means all blocks are green in color, then this automatically becomes true, because some blocks are not red is correct. There is one block which is green and I have one block which is green. Okay. So if this becomes false, this automatically becomes true. Now this happens the same if we start from O. So let's start from O, and if I say some blocks are not red, that means one is not red. Okay. I have green. Okay. So if this is true, this automatically becomes false, because all are not red would become false. And same here, if this is true, this becomes false, and if this is false, this becomes true. So it goes vice versa. Now since we have discussed this, let us move on to this, the relation between E and I. So for E, let's say this is the true statement, all blocks are not red. That means all blocks are green in color, that is a true statement. So if this is true, this should be false, because here I am saying some blocks are red and here there is nothing that is red in color. So this becomes false. So if this is true, this becomes false. Now let me make that true. Okay. If I am trying to make that true, I am saying no blocks are red. Okay. So I am negating that statement. That means all blocks are red. So that becomes false. Then this becomes true, because there is one block that becomes red in color. Okay. So if this statement is false and I don't have green, I just have red, then this statement automatically becomes true in nature, because there is some block that is red in color. And vice versa, if I move from I to E. So if I becomes true, if there is some block that is red in color, then this statement that there is no blocks that are red in color automatically becomes false. So between contradictory approaches, okay, that is relationship between A and O and relationship between I and E. If one is true, the other has to be false. Okay, or in other words I can say both cannot be true and both cannot be false at the same time. At the same time, I cannot say A and O are true and A and O are false. If one is true, one has to be false. That is for sure. Okay, so that is what is contradictory approach. Now let's move on to the next approach, that is contrary approach. Now contrary approach only follows between universal sets. So it follows between a universal affirmative set and a universal negative set. So under this approach, if I say A is true, that means E has to be false. Okay, so for example, I have two blocks. If I am saying all blocks are red, this is a true statement. That means no block is red is automatically a false statement. So if this is true, this has to be false. So this is the first thing that we note under contrary approach. So again it would happen the same from here. If I say this is true, that is no block is red, okay, that automatically means that this becomes false. Okay, so this would automatically become false then. So this goes, the true becomes false and false become true here. True becomes false here, that is for sure. But what happens if I say this is a false statement? If I say all blocks are red is a false statement and I have three blocks here, okay, I cannot say about the truth proposition of this statement. This statement can be true and this statement can be false. I cannot say anything about it, because if I am saying all blocks are red is false, that means I have one block that is green, okay, then there I can say no block, there is no block that is red in color, okay, so that can be a true statement, and there is a block that is red in color, okay, that is again a true statement. So if this is false, I cannot claim about the truth proposition of this statement, this proposition, okay, so this can be true as well as false. So it's very important to understand that under contrary approach, both of them cannot be true. Cannot be true. Okay? So both cannot be true at the same time. If this is true, this has to be false. But if this is false, I cannot say anything about this. This can be true and this can be false in nature. Okay? So it's very important under contrary approach, both cannot be true in nature, but both can be false in nature. If this is false, okay, if A is false, I can say O can be false. If A is false, I can also say O can be true. But I cannot say this if A is true. If A is true, then O has to be false. Okay, that we can easily understand from this example. So this is what is known as contrary approach. Now let's move on to the next approach, that is subcontrary. So under subcontrary approach, what we say is both cannot be false in nature. Okay, so I have some blocks that are red. Okay, so I have the three blocks here. I am saying there are some blocks that are red. If this statement is true, some blocks are not red, I can say that statement can be true and that statement can be false, because if some blocks are red, there is the option that some blocks are not red, and there is also an option that some blocks are red. Okay, so I cannot say about the truth proposition of this statement. So if this is true, nothing can be said about O. It can be true, it can be false. But if I say that this statement is false, that some blocks are not red in color, that means all blocks are green in color, and if that is a false proposition, this automatically becomes true, which says some blocks are not red. So I don't have any block that is red here. Okay, so if some blocks are not red is a true proposition where I have two green color here. So if it becomes a false proposition and I have just green here, then this which says some blocks are not red automatically becomes a true proposition. Okay, so in subcontrary approach, what happens is, if I and O, if I is true, O has to be false. If I is true, there is nothing that can be said about O. It can be true and false in nature. But if I becomes false, that is, some blocks are not read. Okay, if I becomes false, then O definitely has to be true. Because if I am saying some blocks are not read, so I am taking this as an example where there are two green blocks. Okay, so if I am saying some blocks are not read, then the statement some blocks are not read automatically becomes true, because here I have one block, at least one block that is green, okay, and some blocks are not read, so I don't have any block that is red here. So if this is false, this automatically becomes true in nature. So this is what is subcontrary approach. So we have talked about contradictory approach, contrary approach and subcontrary approach. Now the last approach that we would be talking about today is subordination, which is also known as subaltern. Now subaltern says, if a particular proposition is true, okay, only if the universal proposition is true. If I am saying universally all blocks are red is a correct statement, that means at least one block should be there which is red in color. So if super is true, sub has to be true. Okay. So let me first mention it. So under a subaltern approach, if I am saying the super is true, that means sub has to be true in nature. Okay. So if I am saying all the blocks are red in color, that means there should be at least some blocks which are red in color. So if this is true, this has to be true. Now let me make this statement as false. All blocks are not red in color, that means I have at least one block that is of a different color here. So I am making this statement false. Now let's see what happens to this. Some of the blocks are red is a correct statement. So that is true. Okay. So that becomes true. And if I say some blocks are not red, that is again a correct statement because I have one green block here. So that again, the false statement is again applicable. So if the universal is false, I cannot say anything about particular. This again happens the same for this. If I am saying there is no block that is red, that means all the blocks are green in color. Okay, then I can easily say there are some blocks which are not red. That is obvious because you have only green blocks here. So if this is true, this has to be true. But if this is false, nothing can be said about the lower ones, okay, or the particular ones. They can be true, they can be false. So the first important thing in subaltern is if super is true, sub has to be true. But now let's move on to the case with false. Under false, it can only happen is if sub is false. Okay, you can have super as false. So these two are the sub ones. So let me first start with this. If sub is false, that means some blocks are not red in color. Okay. So there are some blocks which are not red in color. Okay. If that is false, then all blocks are red in color, that automatically becomes false, as we can see here. If there are some blocks which are not red in color, I can definitely say all blocks are not red in color. So if this is false, this automatically becomes false. So if sub is false, super automatically becomes false. But if sub is true, if I am saying some blocks are red in color, I cannot say all blocks are red in color. So if sub is true, I cannot say anything about super. It can be true, it can be false. Okay. So if I am saying in this case some blocks are red, but in this case all blocks are red becomes true. Okay. Now let me do this. but all blocks are red becomes incorrect here. Okay, so what is happening is, if sub is true, nothing can be said about super. It can be true, it can be false. But if sub is false, this has to be false. Let me redo it again. So if sub is false, that means there are some blocks that are not red in color. Okay, if that is this statement that some blocks are red in color becomes false, and I say some blocks are not red in color, that means all blocks are not red in color all blocks are red in color is also false, and since all blocks would be here green. So if sub is false, super has to be false. This again happens the same in this case. Okay, so if I am saying some blocks are not red is a false statement, that means there are some blocks that are red in color. No blocks are red again becomes false because all blocks here become red. Okay, so if this is false, if sub is false, super has to be false. Okay, and if super is true, sub has to be true in nature. That is what is subaltern. So in today's class we have talked about the contradictory, where we cannot say that both are true and both are false at the same time. Okay, if one is true, the other has to be false. That is what is contradictory. Under contrary, it applies first of all only to the universal sets. So it's a relation between A and E. And for contrary, I cannot say both are true. So both cannot be true in nature. But if one is false, I cannot say anything about the other one. It can be true, it can be false. Under subcontrary, what happens is, subcontrary first of all is a relationship between particular elements. For subcontrary, if I am saying both cannot be false at the same time. If one is false, the other is true in nature. But if this is true, I cannot say anything about that. It can be true, it can be false. And lastly is subaltern. Subaltern is a relationship between A and I and E and O. Okay. So relationship here and a relationship here. Okay. Here, if super is true, sub has to be true. So if super is true, sub has to be true. But I cannot say, if this is false, I cannot say anything about this. This can be true, this can be false. And the other thing here to note is, if sub is false, this has to be false. I am saying if this statement is false, this automatically becomes false. But if this statement is true, I cannot say the truth proposition of this is this. It can be true, it can be false. So by this we understand the square of opposition. Okay, we have tried to simplify it just with a single statement that all blocks are red. Here it would become a negative for a universal set, that is no blocks are red. Here it would become a particular positive statement, so some blocks are red, and here it would be a particular negative statement, so some blocks are not red. Okay, so we have just tried to understand this concept by means of simple squares and blocks. In the next following class, we would be understanding or discussing some examples based on the square of opposition. So stay tuned for the examples of these class.